Hello and welcome to Unit 6. We are going to be starting your Systems of Equations unit. Before we really get into systems of equations and what is a systems of equations, we're just going to do a little bit of a review on graphing things. This page that you're on right now in your textbook has this whole exploration thing. We're not actually going to do that. So we're just going to skip right down to here and we're going to jump right to question A, which says draw these graphs. Like graph those two equations. If you want, you can put it in context with the information above. You can read that if you want. It just makes this a word problem, but I'm not so worried about the word problem. I'm much more worried about these two equations and remembering how to graph them on something. So we'll start with the one that I've underlined in red. Our goal is to graph that equation. To be able to graph that equation, you have to be in the form y equals, right? Like that is how we graph things. So you must have to graph. Essentially, what you need to do is you need to isolate y, get y by itself. So if we're looking at that first equation, which is 3x plus y equals 11, and we want to graph that thing, we need to get y by itself. To get y by itself, we move things away from it. So the thing that we need to move away from it is this 3x. We need to move it to the other side of the equation. We do that using opposite operations. That is a positive 3x being added to y, so we need to subtract 3x so that it cancels out on the left side, and what you do to one side in math, you do to the other. So that you now have y equals 11 minus 3x. I'm going to reorder that because to me it's easier to have things like this. I like to have my x variable first and then my constant, the 11, at the end. Once I'm in that, the y equals form, I can graph this using my knowledge of y equals mx plus b. And we learned about that last unit, right? Where m is -3 is my slope, and where b is my y-intercept. So I can graph this by starting and putting a dot at my y-intercept. Okay, I know my line is going to go through that point right there, positive 11. And then I'm going to use my slope to find the next spot. My slope is -3. So, sorry. So that means I go down 3, 1, 2, 3. And if there's no denominator to your slope, that means it's a 1. So we move over 1. And we hit that point right there. Once you have 2 points, and you know you have a straight line, which we know because it's y equals mx plus b, we can draw a line straight through those 2 points like that. That line's not very good. When you're graphing by hand like we're doing, you want to make sure that your line is really going through both points and use a ruler. Okay, so you want to be as straight as possible and go through both points as much as possible. That line technically would go on forever in both directions, so if you want to put a little arrow on the end of it, that works too. That's how I would graph that red line. If you want to pause and just see if you can graph the blue line on your own, that'd be a good idea. Just give it a shot. Cool. Hopefully you paused and tried. This is how you would do the second one. So if I look at my second equation, it's 2x plus 3y equals 12. I'm trying to get y by itself, so I need to move two things. I need to move the 2x to the other side. I also need to move the 3 to the other side. If you can't remember which way to do it, so which things to move first, whatever's furthest away from the y, you need to move first. So the 2x is further away, so I can move that by doing minus 2x to both sides. And what you do to one side, you do to the other, like that. That gives me 3y equals 12 minus 2x. Now to get rid of this 3, I need to remember that is 3 times y, so I have to divide both sides by 3. When you do to one side, you do to the other. I like to show it like that. So those 3's will cancel over here. And I now have y equals 12 divided by 3 is 4. minus 2 divided by 3 doesn't work. It gives me a decimal. It gives me 0.66666. So I'm going to leave it as a fraction like that and then put the x to the side. So remember that 3 is actually just going with the coefficient, the 2. And again, I'm going to reorder this. So it looks like this. Oh, sorry. I like to put my constant value first. So this minus 2 over 3 is going to go first. And then that positive 4 is going to go at the end. And then I can graph it because this is my y-intercept. This is my slope. So I draw a dot at my y-intercept of 4. 1, 2, 3, 4, right there. My slope is down 2 over 3, so down 2 over 3. And then I can draw a line through those two. I go draw my line. I try my best to make sure I go right through both points, like that, and make it as straight as possible. Awesome. So what we've done, I'm putting arrows on the end just to remind you that these lines do go forever, right? Like if we hypothetically just had 2 lines and we graph them, they go forever and ever and ever and ever and ever. Hopefully, we remember how to do that and how to graph these beautiful things. Now, what this unit is called systems of equations. What that means is that you're going to have equations, which we're used to at this point, but we're going to have more than one equation at a time. That's why it's called a system. So for instance, this right here is a system of equations because I have 2 different equations there. I have the red one and I have the blue one. To solve a system of equations means that you want to take both things, both equations, and you want to figure out where those 2 equations have the same x and the same y value. So for instance, if I look right here on the red graph, that point, that has an x value of 1 and a y value of 8. So an input of 1 gives an output of 8. If I look on the blue graph right here, that gives me an x value of 1, so an input of 1, and we're going to say an output of 1, 2, 3. It's going to be like 3 point, we'll say 5. It's not actually, but that's okay. We're just estimating 3.5. And you'll notice that those 2 points, the one on the red and the one on the blue, are different points. They both have x values of 1, so they have the same input, but they both gave the same output. A system of equations is trying to find when they have the same input and the same output. For us, we call that where they intersect each other. So what this unit is going to be about is going to be about figuring out where 2 lines intersect each other. These 2 lines intersect right there. They both have an input of 3, and they both get an output of 2. It works for the red line, and it works for the blue line when you do that. Kind of cool. Systems of equations actually are very applicable in real life. Moving forward, we'll continue doing systems of equations for the next 2 years, grade 11 and grade 12. And you will see we can build very complex equations that represent things in the real world. And then you have to figure out where these equations match up with each other and they balance out. So where they share the same input and the same output. You see a lot of this in like business, economics, stuff like that, where you're trying to do business models. You also see it a lot in science, which is kind of cool stuff. That's what this unit's going to be all about. It's going to be figuring out where 2 equations cross each other. The best way to do it, usually by graphing. That's why we did our practice of graphing. So we're going to slide down here. This, if you didn't understand what I just said, maybe read this, and it'll kind of explain what I just said. It's saying that a solution to a system of equations is when they have the same input, same output for both lines. Read it. Maybe it'll do a better job explaining than I did. Example 1. A system of equations has been represented on the grid. If you look over here, there's a system of equations. I know there's a system of equations because there's 2 lines, right? I have 1 line right here, my blue line, and I have 1 line right here, my red line. That makes this a system of equations because there's two lines being considered at the same time. If I want to find the solution or I want to solve a system of equations, you're trying to figure out where those two things intersect, where they have the same input and the same output. Looking at this graph right there, those two lines intersect. They both have an input value of 2, so an x value of 2, and both get an output value or a y value of -1. So the solution to this question would be x equals 2, y equals -1. If you wanted to write it as an ordered pair, we'd call it 2, -1. Wicked. That's what this unit is going to be like, right? Take a system, solve it. Here's another one. Not quite as easy because they haven't graphed it for us. So it says, consider the system of equations 2x plus y equals 2 and x minus 3y equals 15. Graph the system of equations without using technology. Okay, so to graph things, we know we need to take the equation and turn it so that y is by itself. To do that, I need to move the 2x to the other side, like that. When I do that, I end up getting y equals 2 minus 2x. I prefer to write the y value or the x value first, so I'm going to make it -2x plus 2. To graph it, I start with my y-intercept. My y-intercept is -2, so I'm going to draw, +2. So I'm going to draw a dot at +2, right there. Then I'm going to use my slope value, which is -2, to find my next point. So I'm going to go down 2 over 1 to right there. And you could keep doing that. Like if you wanted, you keep going down 2 over 1, and you would get a whole bunch of points, and you would notice that it's creating this nice straight line. Or you could just take your ruler like that and just draw a nice straight line through. I like to put arrows on the end so that we know, oh yeah, this graph, it goes forever. Perfect. Now we have to draw the other equation so that this becomes a true system of equations. To draw a graph from an equation, we have to have y by itself. So I'm going to have to move the x first, like that. So I have -3y equals 15 minus x. And then we have to divide the -3 from all the constants and coefficients over here. Cool. Looking at this, these -3's would cancel. So I have y equals 15 divided by -3 becomes -5. Perfect. The next one's tricky. So you have to remember that there is an invisible 1 right there. That is -1x. So what I'm really doing is I'm doing -1 divided by -3, which will become +1 over 3. We don't like to use decimals. We like to use fractions. So that becomes 1 over 3x. And then I can graph this thing. The -5 is the constant. So that is my y-intercept. The 1 over 3 is my slope. If I go up 1 over 3, like that, it'll give me my next point. Up 1 over 3, up 1 over 3, like that. And then I can just connect the dots to figure out what my entire graph would look like. There we go. We've successfully graphed our two equations without technology. I call it by hand graphing. Part B says state the solution to the system of equations. The solution is where these two things intersect, where they have the same x value, the same y value. They have the same input, same output. Looking at this graph, it's pretty obvious. That right there is the solution. That has an x value of 1, 2, 3, and a y value of -4. So my solution is 3, -4. That's the solution. Perfect. Part C is kind of one of the cooler parts about this unit. It's called verifying. So verifying means like checking your work, essentially. Okay. And the way that we're going to check our work is by going to these equations up here that we built. I'm going to just highlight them in orange. Going to these equations and giving the input value of 3 and seeing if you get the output value of -4. Right? Because we said that those two lines cross at 3 comma -4. That means that if I was to go and actually put that into my equation and change y and x to be the values I said, would it work? So for instance, I'm going to go to this equation. I'm going to change y to be -4. And I'm going to change x to equal 3. Like that. And to verify means to calculate both sides of the equal sign. On the left side, a -4 is just -4. So I'm going to put that -4. On the right side, -2 times 3 is 6, or -6, plus 2 is -4. And you'll see that both sides of the equation worked. That means that equation is correct. That means we verified our solution. That equation does have an input of 3 and an output of -4. It is a possible thing for that line. We also could verify for the blue equation. So if I take my equation and I want to verify my work, then I'm going to change my y value to be -4. And I'm going to change my x value to be +3. Then I'm going to put in my calculator. So -4 just equals -4 still. Then we want to do 5 plus 1/3 times 3. You'll notice it becomes -5 plus 1, which is -4. That is a verified solution. One of the best parts about this unit is that you can always check to see if your answer is right. So take your answer, verify it by putting it back into the original equation, and see if both sides equal each other. It's kind of one of the best parts of this unit. Okay, you can go ahead and you can complete a couple questions on the assignment if you want. I just realized that that's a spelling error. Hey, complete. Right? We should be completing them. And then unpause the video and come see how to use your calculator. Okay, so the beauty of this equation is you can graph things to try to get the solutions. We just did graphing by hand. Now we're just going to talk about graphing with a calculator. The steps are all right here. I really can't help you much more than that, giving you each individual step. Anything in a box, so when you see like they put a box here, that is what they want you to do on your calculator. So you actually find the button that says y equal and you press it because it's in a box like that. We're just going to jump right down to an example and we'll talk it through on how to do this with a graphing calculator. And you can try it too at home. And if you get stuck, that's okay. That's completely normal. Just keep trying, try to follow the steps, maybe ask a friend. It helps maybe to do that, or ask one of your teachers. Be like, hey, can you show me the buttons to push on a calculator? Maybe with like a Zoom or a Google Meet or something like that. Okay. So let's consider the system of equations from the explanation at the beginning of the lesson. Rewrite each equation in y-intercept form. I'm just going to skip this pretty quick. We'll do this one as red. That one in y-intercept form would become y equals 11 minus 3x. Awesome. This one in blue, if we remember, it became y equals 4 minus 2 over 3y. Or x, sorry. Like that. Cool. Use a graphing calculator to graph each equation. So I want you to try on your graphing calculator right now, pause the video, go up to these steps and follow these steps up until here. Okay, up to number 5. You will have to have your calculator with the proper window. So before you do these things, it might be a good idea to go click your zoom button. It's right at the top. Okay, and then click number 6, zoom standard. And what that's doing is it's setting up your calculator to just be in a window that's basic. It's just positive, negative 10. So your window will look like this. And negative 10 out here, 10 out here, 10 up here, negative 10 down here. So it's just giving you a nice little graph when you do this steps, Zoom standard. Okay, go ahead, try to graph that question from below right here. Okay, hopefully, if you did that, your calculator should have given you something like this. So you would have had your window. You should have had one equation, which went kind of like this. And you should have had another line that looks something like this. Yeah, give or take, something like that. If you didn't get that, some major mistakes that people make, this, like, oh, sorry. When you're putting on your calculator, that is a minus sign, right? Not the negative sign. So the negative sign is right next to the decimal in your calculator. You did not want to use that. You want to use the minus sign or the subtraction sign. It's right above the plus symbol or the addition symbol. Right? If you use the wrong one, it will mess up your graph and look kind of crazy. Sometimes people forget to click X, or they don't know how to click X into their calculator. The X button is right next to the alpha button. It's usually a different color, and it has this. So mine is X, T, alpha, N. Right? That's the button you want to click to be able to get X. Awesome. If you still kind of are trying to graph it and you can't get it, that's okay. Maybe ask for help, ask a friend. If you have an older brother or sister who's taking the course, that would be wonderful. Yeah, just try your best. Graphing becomes a major struggle early on when we're learning it, but if you get good at it, it helps tremendously in future grades. So it's something you want to fight through those struggles right now to get good at. Hopefully you got good at it a couple units ago when you practiced it. Okay, part C, state a suitable window which shows both the x and y intercept of the point of intersect. We've already talked about setting windows here from previous unit. So if you click your window button, it's right at the top of the calculator, you will see it says like x min, x max, x scale. And then it'll say x or y min, y max, y scale. And what that's doing is it's setting up your graph, those black lines that I have up there. You always want to be able to see on your graph your x-intercepts and your y-intercepts. So if I look up at my graph right now, my window is pretty good. I have a lot of dead space over here. Right, so we usually try to like minimize dead space. So currently I have an x maximum of negative 10. I could maybe bring that in to about here so I don't have so much dead space, which is probably about negative 5. So if you change your x minimum to negative 5, that'd be fine too. Your x maximum actually looks pretty good. There's a little bit of dead space, so we could maybe bring it in a little bit, but I actually like that x maximum of 10. And scales, I just always leave it 1. That means your graphs count by ones. Your y minimum, again, we have kind of a lot of dead space down here. So we were at negative 10. We could maybe bring that up here to about negative 5 as well. And our y maximum's actually not big enough. It's close, but we can't see this y-intercept, right? We know it's there, but we can't see it really well. So that currently is at 10. If I want to go up and see more, I'm going to actually just make it 15. And the scale, I always leave it 1. Awesome. Part D, I want you to solve the system of equations. To solve a system of equations is to find where they intersect. The instructions on how to do that is up here. So if you want to give it a try right here, give it a go. I'll talk you through it right now. So you're down here, you're on your graph, you're going to go graph, second, trace, intersect is the 5th option. You're going to hit enter 3 times. And on the bottom of your calculator, it's going to say intersection x equals 3, y equals 2. That means your answer is 3, 2. You could write it like that, or you could write it as an ordered pair. Those both mean the same thing. That's how you solve a system of equations using your graphing calculator. It's hard to do that online. Like, it's normally you would be probably sitting with your teacher, going step by step, seeing the buttons get pushed right in front of you. Unfortunately, that's hard to do right now online. So if it's hard, if it's really confusing for you, that's normal. This is usually one of the harder things that people do, but once they get it, they're awesome at it. Awesome. Down here is instructions for if you want to convert decimals into fractions. You don't need to worry about that too much. We're going to do this last question right here, and then we're going to be done for the day. So it says, solve the system of equations using a graphing calculator. This system, if you look at it, uses the letters A and B instead of X and Y, which means your calculator can't do it because it doesn't know what A's and B's and X's and Y's are. So what we do is we change one letter to X. I'm going to change A to become X, and one letter to Y. I'm going to change B to be Y. And then I can actually solve it. But I have to make sure I know which letter's which. I said A is Y, B is X. And then I do the same thing for the other equation as well. Change that one to be 3x equals 14y. I want you to try, pause the video right now, see if you can get y by itself, see if you can graph it. Awesome. Hopefully you did that. To get the first one, so y is by itself, we're going to move that 6x to the other side. So I have 7y equals 5 minus 6x. And then I'm going to divide by 7. And that gives me y equals 5 over 7, because that's a decimal, we leave it like that, and 6 over 7, because it's a decimal, we leave it like that, x. If we look at the blue equation, we want to get y by itself, so we divide both sides by 14. That gives me 3 over 14x equals y. Awesome. And now you should try to graph both those things and see if you can find the solution. If you graph, sometimes putting brackets around fractions in your calculator helps, just to remind your calculator, oh yeah, that's a fraction, it goes together. So I put brackets around it. Awesome. If you graph this, I just use the standard window again. So zoom 6, that's the standard window where it's tens all the way around. My first graph looked kind of like this. Started way up here, kind of cut through down like that. And my second graph was very much a horizontal line, kind of looked like this. Awesome. To get the solution, I went second trace intersect, number 5, and then hit the enter button 3 times. And you would have found that these two things cross each other right there at 0.6 repeated, comma, 0.14, like that. So my answer would be 0.6 repeated, comma, 0.14. That's if I round it. If you want to write those as fractions, 0.6, you might just know, is 2 over 3. But the 0.14285714, if you wanted to try to change that into a fraction, you just go back to your regular home screen and you type that number in. So 0.14285714, type it in your calculator, and then hit the math button. And the first option is frac. And hit enter on that, and then hit enter one more time, and it'll turn it into a fraction for you. In this case, the calculator is like, woo, that we don't know that fraction. It's still 0.14. So the calculator actually won't change it into a fraction for you. I believe almost all your answers are always like round to the nearest tenth if it's a decimal. So don't sweat too much about changing things into fraction answers. Part C is algebraically verify your solution. If you want, you can plug those numbers into verify them. We're not going to go through that. This has been a long enough video for you to try to handle things. Okay, take care of yourselves. I hope you enjoyed this. I hope it helped. See you soon.